Our session today will cover Oracle Intro to Cloud Security, the OCI security solutions and services that are available today, what's planned next, some advantages customers have, and how easy it is to get started. I'd like to introduce Josh and Andre as our main presenters. And now I will hand it over to Josh to start today's session.
Hi, everyone. My name is Josh Hammer. I'm the Field Chief Cloud Security Architect here at Oracle. Andre, want to say hi?
Hi, everybody. Thanks, Josh.
Appreciate it. So I was actually thinking about it earlier. It's been almost 5 years since I've been back at Oracle. And one of the most interesting opportunities I had when I came back was it was about end of 2019. And Oracle had really put together a robust security architecture internally for OCI based on its design paradigms of bare metal. And they were looking to build out the customer side of things. And when I left AWS to come here, part of the advantage was they're like, hey, it's like a startup, so there's a lot of opportunity to fix and build and really be part of the foundation that we're going to build. And what you're going to see here is a lot of what our teams have put together to really build and explain how security can work on OCI. All right. So OCI, as I said, kind of started off as this concept around how to deliver bare metal cloud computing. And it's actually Oracle's second generation cloud because we actually built a first generation cloud. And the reason we actually started to build a second generation cloud is we wanted to get better performance, better security. And we did this by starting from the bare metal approach. We wanted to give you as close to direct CPU access as possible, and we wanted to give you the fastest network access possible. And to do those two things, we actually helped to develop a couple of key components which are part of Oracle Cloud Infrastructure. The first is this very lightweight kind of shim of a hypervisor, and the other is the shim of a hypervisor concept is basically that there's certain operations that virtualization occurs that you don't necessarily need to always pass through. So there's not a heavy, like you've installed software on this bare metal instance to be a virtual server and then virtualize infrastructure on it. We're giving you as close to the direct CPU execution as possible. And then we also had to build a slightly bigger one where we had to give you a bit more virtualization. You see that on the right side where you can spin up full virtual instances versus taking an entire box. And the other thing we did, which was very interesting, is we basically realized that the network also needed to be abstracted out. So we actually have network cards on each of these compute instances where all the network operations are offloaded to. So the CPU is not having to do any network-based translations and everything like that. And that actually gives us two really interesting security advantages. The first one is that to break out of a hypervisor, which when we were building it, actually, that was a big thing. There was things like row hammer. No, it was not hammering RAM cells, and a few others that had theoretical proof that hypervisor breakouts were possible. And the way we did the virtualization in the bare metal meant that even if you managed to kind of break out of the bare metal through this virtualization attack through like rowhammer, the network card, because it was not part of the virtualization infrastructure, would not be hampered. So you could take over, in theory, a box, but you would never be able to move laterally because the network card would not allow it. The other thing that we did that was interesting is that network model, we actually encode at both the network security at both the network cards. So every rule that we use to segregate our traffic is at the network layer, at network card layer, and also at the physical layer, and also back again at the thing. So there are 3 checks for every packet. And the other thing we did is we realized because we had all this basically similar to firmware running on raw compute, running on our hardened hypervisor, and running on network cards, we needed a really fast way to make sure that everyone got clean, pristine instances whenever they start a new instance or whenever we have to build out a data center. And we did this through our hardware root of trust, which basically guarantees you signed, pristine code every time you reestablish a new instance, for example. And then we also had to figure out how to design a couple of other key concepts. The next thing we looked at is like, while this infrastructure is great, we needed to make sure that we were able to be redundant. We all live in the world of the CI triad of confidentiality, integrity, and availability. And we wanted to make sure it was available. So we created this concept of a fault domain. And a fault domain is an isolated set of infrastructure with its own power internet residing in what we call an availability domain. Each availability domain has 3 fault domains. So thus, any one of them is cloning certain resources around so that one could fail, one and still be available. Inside of that idea is, on top of that is an availability domain. And an availability domain is one group of at least 3 fault domains. And then a region is a collection of one or more availability domains. And what you'll see in some of our larger regions is that you'll see that we'll have multiple availability domains where, anywhere from 3 or less, some more. And in regions where you'll notice that we might not have as many availability domains because the minimum amount is 1, we'll generally have a region very close to it in the same country or in the same geographic region to allow the ability to do failover. So not only did we think about the ability to failover inside of a region, but we also wanted to make sure that we could support it for failover across regions. And I think what's really amazing, and this goes back to the design paradigm of that hardware root of trust and the ability to kind of move as much to, kind of the, at the kind of infrastructure as possible, is that we're able to build over 171 regions extremely quickly. And what you'll see here is not only did we build these regions out extremely quickly, we've also built the concept of being able to build regions at other clouds. So when you see these Oracle database at Azure or these Oracle database at Google Cloud and soon at AWS, what we're doing here isn't just them running ours. It's actually us deploying a version of Oracle Cloud Infrastructure in their clouds that allows them to run the OCI just as they would if they were running in our own global regions. And that has required a huge amount of really innovative pieces, which you can see were built in the original infrastructure of bare metal. So it's a very exciting way to get customers access to that infrastructure. And then you'll also see that we have the ability to give customers dedicated regions and even something called Alloy, where customers can run clouds for others. And Alloy, for example, is identified based on is in the country, regardless of the number of actual deployments within there. So how do we actually monitor and manage this? And that's the exciting part. So in general, there's a lot of regions and you're thinking, well, how do you do it? Well, part of it is that we rely on the telecommunications industry associations ANSI standards, either tier 3 or tier 4 for our redundancy model and our data centers. Every one of them is physically secured with both physical security outside, video monitoring of the infrastructure, hardened access to those pieces. And then we have a team of security operations professionals responsible for monitoring this infrastructure. And they are watching it 24/7, 365, except on a leap year where they get that extra day of work, to detect all those activities going on and available. And this is across the board. And then it ties into Oracle's cybersecurity organizations, where our global information security policies are the guides for it. We have our product teams that are also monitoring it and our legal teams. And what's really interesting about this is that since Oracle has been developing software for over 40 years, a lot of the security designs and paradigms that we take into approach around security-minded leadership, embedded expertise, using common security standards, openness, and training are actually the same paradigms that Oracle has been using to develop software. And we call that the Oracle Security Software Assurance System, which is the way that we're able to help achieve a variety of different compliance frameworks. And what's interesting here is that a lot of compliance frameworks all use standard concepts and ideas. They all have some overlapping and similarity, and most of them align back to how Oracle has been developing software for, like I said, 40 years. So what's really useful is that we've had these practices, they're embedded in our organization, and they're very common to how we develop software and how we offer services, because we've been doing that for a long time. And these processes follow through our infrastructure layer all the way up to our SaaS layer in Fusion, where those same concepts are what we follow to deliver that security model. And what's also interesting about that security piece of those teams, we actually have an Oracle Threat Intelligence team that actually is monitoring our entire infrastructure. And we can actually share some of that information directly with our customers through OCI with the Threat Intelligence service. So shared responsibility. Now, as I'm sure many of you have been using the cloud for a while, are familiar with the concept. And as I always like to say, there are mostly it's kind of like being a lawyer. You're always practicing. No one's ever an expert. And the reason is that the shared responsibility model covers a variety of different things. And this high-level guide is what I think most of us are comfortable understanding. The idea that in certain areas, I have more responsibility, and in other areas, I have less. And there's the extreme of where I own everything and I delegate everything, right? The on-premises versus the SaaS approach. Now, the OCI pieces, for the most part, that we generally talk about sit in the IaaS and PaaS space. But our Fusion SaaS applications are actually provided on OCI. So Oracle, obviously delivering all three of these pieces, has this unique opportunity to understand the shared responsibility model extremely well and try to help guide customers through it. And the way I like to kind of think about it is that shared responsibility, and I'm going to take it from an infrastructure perspective, isn't always the same. So I always like to start off with a couple of examples to get you started. And this is where I think you'll see how we're trying to be more helpful in this area. So generally speaking, one of the kind of most granular types of infrastructure as a service is compute. And that's basically where we give you a virtual machine that you can use. Now, OCI isolates that instance, as you saw in the bare metal compute design or in the shared VM running in the secure hypervisor. We encrypt the boot volume and the block volume that are being used for it with our Oracle managed key. And then at which point it's your responsibility to determine who has access to the SSH keys, what network ports are open to it, and that type of access. And then we strongly recommend that you tag it. Tagging is a way to put a metadata attribute on an instance. And the tags you can use for things like cost allocation, ownership, data classification. Now, another piece of infrastructure as service is object storage. And object storage is the equivalent of a folder. And that folder is where you simply store files. And in this case, what we're doing is we're providing you with the secure folder to store, and we're encrypting that bucket for you with our own customer managed key. But there's no updating of it. There's no determining who has to run updates on the server. And in general, what's interesting here is that the key area that you have to do is determine who has access to the bucket and when and how those bucket objects should be managed. And even with encryption itself, we have the ability for you to bring your own encryption key or use customer managed keys, which goes to the concepts that we developed. And this is what I think is really unique about our approach. The point that we're encrypting the data at rest for you with our customer managed keys, no matter where you're storing it in object storage or bucket storage, provides that simple and effortless approach, right? I got encryption, I know it's on. We allow you to deeply integrate by developing your own key, for example, or to use our own key management service so that the customer can manage it so you can have it. And then we connect these services across IaaS and SaaS so that you can use that same key how you need, or you can manage that key. And then we allow you to not only deploy that infrastructure, as you saw in our data centers, in your own data centers, and when you pick your regions, you don't actually get all regions. So when you create an account with us, it's called a tenancy. And that tenancy itself does not give you all regions. You have to subscribe to them one by one. So you really have the ability to have a really simple, effortless, tightly integrated, and where you control access to your data running on our cloud. And that is through the variety of security services that we offer. And this, I think, is the fun part, because putting these pieces together is what Andre is going to talk about shortly. And I'm going to start from the center, because identity is generally, especially with now the concepts of zero trust, the heart of security. So we actually created this concept of a compartment, and a compartment is really unique construct. If you think about it, it takes into account the old Unix operating systems and mainframe operating systems of shared infrastructure. And it is a folder where you can use to put things in, whether it's compute resources or object storage buckets or anything. And then you associate policies with it, very much like a Linux file system, right? You can put permissions on the folder, you can subfolders, they can roll down objects. That dual mind system allows you to create very granular controls across the board. And it also, because just like a Linux folder system, you can share folders. If you have to share certain things, you can actually share them across. So if I wanted to share my networking with the rest of the team, I can do that. And those are all managed through our compartments, policies, identity, obviously supporting federation and integration. And then we have preventative controls to help you lock it down. Then I'll go back to the data security. As I said, you can bring your own keys. You can encrypt with our own KMS storage, which is an HSM FIPS 142 based backed security. Bring your own, use certificates to encrypt data in transit. Have your ability to determine how you want to get your compute, whether it's serverless functions or Kubernetes, or if you want to go bigger and you want to run an infrastructure server or a database, or take over a full server and run VMware. All of those are the different types of operating systems we're offering to you. We provide you with a virtual cloud network, which allows you to build your own networks in the cloud. And what's great about virtual cloud networks is that it brings that concept of segmentation to a very unique level, whereas back in the old days when we had on-premises, we didn't have the ability to flex through everything. Now you can build micro networks for just certain features. We have network security groups to control micro access to different things. We have a network firewall powered by VM series. We have a bastion service that allows you to get access to it. And then if you go up a level about how do you monitor and detect things, we have a variety of controls like our Cloud Guard, which is a cloud security posture management moving into the CNAPP space. We have logging, which can integrate with all of your third-party tools to give you all the information, both services and networks. And then we have edge security from our WAF application. And by default, we're going to take care of DDoS layer 3 and 4 for you to keep our infrastructure. But as Oracle is a multi-cloud player, and we want to make sure that you have the ability to use those same security tools that you use on premises and other clouds on OCI. Now, this is not a holistic list of all of the different tools we have in our ecosystem, but these are ones that I've categorized based on it. And, for example, you have the ability to manage your keys with fails. You have the ability to deploy secure compute images based on the CIS hardened standards. You could pick your favorite firewall of choice. Hopefully it's up here. If not, it might still be in the marketplace. Connect with your identity providers of choice and use your favorite logging solution to aggregate all of your logs into your security event monitoring system. And then you can also decide to use your own cloud security posture management tool to check the infrastructure of OCI. Now, you're probably saying, what does this have to look like? And it goes back to, remember, simple and prescriptive. And to do that, we've actually automated this based on our best practices, our reference architectures, and we've automated both the deployment and the detections of it into what we call the OCI landing zones. And to talk more about the OCI landing zones, I'm going to turn it over to Andre.
So thanks, Josh. Folks, as Josh showed us, OCI has a broad set of services, right? And it can be a bit challenging to make the best design decisions, especially if you're new to OCI and timelines are strict and you need to deliver quickly, right? So to best help our customers fulfilling their share in that shared responsibility model, we offer the OCI Landing Zones framework that delivers a set of architecture and security best practices in an easily consumable way. So it's like your architecture and security best practice in a box. And OCI landing zones are based on CIS Foundation's benchmark for OCI. CIS here is Center for Internet Security, a nonprofit organization that defines best practices for the cybersecurity space, right? And OCI is now on the benchmark version 2.0, and this version covers all these 6 buckets that we see here in the screen: network, compute, IAM, compute, networking, logging, monitoring, storage, and asset management. And the reason why we picked CIS as the base security framework for landing zones is because the recommendations are very concrete, leaving very little room for subject interpretation. And the benchmark, the other thing, it gives us a direct path to CIS controls, of course, right? And from the CIS controls, we can crosswalk to virtually any security framework in the industry, like NIST, PCI DSS, HIPAA, FedRAMP, etc. And the OCI Landing Zones framework was announced in OCW 24, and it essentially brings together multiple initiatives, including the existing CIS Landing Zone, OCI Enterprise Landing Zone, and operating entities landing zones for our friends in EMEA. And the framework essentially consists of Terraform-based components that are split in blueprints, extensions, workloads, and modules. Blueprints are specific architecture designs with their accompanying infrastructure as code templates and documentation. And they essentially help with the quick onboarding to OCI. A blueprint is the main landing zone interface into OCI. It is that component that customers will mostly interact with when provisioning their resources through this framework. The extensions are pluggable components that extend a given blueprint design, like picture a custom hub spoke configuration, multi-cloud connectivity, right? Just to name a few. Landing zone blueprints and extensions together, they form the tenancy architecture foundation, like a secure airplane runway where you can safely and quickly deploy aircrafts. Or another analogy would be the foundations of a house with the flooring, the walls, electric plumbing, ceiling, ready to take in any residence. And landing zone workloads are pluggable components that simplify the services onboarding for specific applications, like cloud-native apps, VMware, Exadata Cloud Service, Business Suite, AI services. So it's what you deploy on top of a landing zone in more simpler terms. Blueprints, extensions, and workloads, these three elements, they leverage a set of base Terraform modules that help with CIS benchmark compliance. The two main takeaways about these base modules are the following. First, they enforce CIS recommendations whenever possible. And second, they expose an abstraction layer that allows the usage of JSON documents, or YAML for the record, to represent any desired infrastructure, architecture infrastructure, or infrastructure architecture, sorry about that. Currently, we have 3 available blueprints in the framework. We have the OCI Core Landing Zone that we are covering in this presentation, mostly. We have the OCI Zero Trust Landing Zone, and we have Operating Entities Landing Zone. The Core Landing Zone unifies CIS Landing Zone and the OCI Enterprise Landing Zone in a single code base. If you're familiar with CIS Landing Zone, you see that the architecture is very, very similar. And it also incorporates a few elements of OCI Enterprise Landing Zone that were not available in CIS Landing Zone. The Zero Trust Landing Zone is a variation of Core Landing Zone with specific settings for enforcing zero trust concepts, like continuous traffic inspection, zero trust packet routing, access governance, and integration with third-party zero trust network access appliances. The operating entities landing zones actually provide multiple blueprints. So the operating entity is a collection of blueprints that take into account organization functional divisions like subsidiaries, departments, projects, things like that. And one particularly interesting blueprint is the CIS Landing Zone reference implementation. We're having the link in here. That essentially facilitates the onboarding of multiple customers into an ISV managed landing zone. In the next few slides, I will be talking about the OCI Core Landing Zone. And if we were to summarize its principles, we could say that first, it implements the CIS Foundation benchmark for OCI, right? It implements architecture and security best practices that we bring in with the help that we provide to our customers and even OCI services. It prescribes a specific solution, making a bunch of decisions based on a few exposed configuration parameters. It is automated by Terraform. and it mostly deploys resources that are included with your tenancy subscription. There are just a few optional scenarios where charges are incurred. And last but not least, it is available publicly in GitHub. And by the way, we do welcome contributions. So zooming in into the core landing zone, as I said, it builds upon the CIS landing zone architecture. If you're familiar with it, on the right-hand side, you have the diagram, so you'll be able to recognize that. And in a way, we can treat the core landing zone as an updated version of the CIS landing zone. And it follows what we call a centralized deployment model or programmatic style landing zone. Why? Because it's typically deployed by a single individual in the push of a button after entering values for some configuration parameters. And programmatic because the backend is a Terraform program, if you will, that makes decisions based on the given configuration parameters. And it invokes those backend modules for actual resource provisioning. The core landing zone can be deployed with Terraform CLI straight or OCI Resource Manager service. The OCI Resource Manager service is essentially Terraform as a service, and it offers some very interesting functions like one, state file locking and configuration drift detection. If we compare the core landing zone to the CIS landing zone, its predecessor, we can say that the core landing zone adds the following. First, a streamlined user interface, the support for bringing your own identity domain. We don't have that in CIS landing zone. We only support default identity domain there. We now bringing support for cloud native oriented VCNs. We have enhanced our hub spoke networking module, supporting inline deployments of third-party firewalls. Currently, we support Palo Alto next generation firewall and Fortinet's FortiGate, and of course, OCI network firewall service. And last but not least, we now support zipper policies that adds an additional flexible and easy to use layer of security to the existing network security groups. Now, zooming in more into that diagram, right, that we had on the right-hand side. So the very first thing that I'd like to highlight here, and it's one of the, the very first thing that the CIS benchmark recommendation gives us, and that shapes this diagram or this architecture, right, is related to segregation of duties. And here in the diagram, we see, in those colorful boxes, the big ones, right? They essentially represent compartments, and Josh gave us a good overview on compartments. And compartments are the very foundational resource of any tenancy in OCI. And they are used for organization purposes, and they aid a lot in access control, right? And the landing zone deploys up to 6 compartments in this specific hierarchy that we see here on the screen, right? An enclosing compartment, the gray one, with up to 5 children compartments in it. The green compartment for networking resources, the yellow for security, the blue for application or your mid-tier resources, if you will, the purple one for database resources, and the red one for Exadata resources. And aligned with these compartments, the landing zone deploys a set of groups to manage resources in these compartments. And in other tenancy locations, by the way, as at the global level in the root compartment, right? And the management capabilities are expressed by these colorful arrows that we see in the screen that are, coming from the groups, right, to compartments. See the green arrow, the yellow, there are blues, the purples, and reds. And there are, and as I said, they express management capabilities, but there are also some implied usage and reading capabilities, right? We go beyond just management capabilities. For instance, to support the use case where database administrators needs to deploy databases in the network, right? Database by themselves deployed don't mean anything. They need to be in a network so they can be available. So what happens is the landing zone provides necessary policies that allow administrators to use resources in the network compartment that were created by network administrators. So in a sense, database and app administrators, they don't have a say in defining the network, right? That's a duty of the network administrators. And the same principle applies for security, the resources in the security compartment, right? Organizations typically have a security organization that manages security-related resources. And talking about security, among the OCI security services, here we see CloudGuard, we see zipper policies in the root compartment. And within the security compartment, we have the Vault service for key management. We have the vulnerability scanning service. We have the service connector. Service connector is an interesting one because it aids in the collection of logs across all OCI services in the tenancy on behalf of integrating, those logs with an external SIEM service. And talking a little bit about the resources here in the network compartment, what we see here are VCNs, right? Virtual cloud networks. And the landing zone supports VCNs for 3 types of workloads. The typical 3-tier, good and old 3-tier applications, Kubernetes-based cloud-native apps, and Exadata cloud service workloads. And it supports up to 3 VCNs of each type of these, right? It's not OCI, it's not an OCI limitation, just to be clear. This is the landing zone automation, right? The Terraform automation supports 3 types of each of these VCNs. And these VCNs, they can be paired together by the OCI DRG service, the dynamic routing gateway, and connected to your on-prem data center. These VCNs are primarily secured with network security groups, these little circles here, and they can have an additional layer of security implemented with Zipper, Zero Trust Packet Routing. We have some grayed out components in the application database and Exadata compartments. They are not deployed by the landing zone automation. They essentially represent the application workloads, and they are an indication where the landing zone expects them to be deployed, right? So they are like the day 2 of your OCI journey, right? After you deploy your landing zone, then you're ready to bring in your residents, right, to this beautiful house. Now, zooming into the networking compartment, I'd like to highlight that within that, besides the 3 types of each VCN, 3 VCNs of each type, we also can deploy a DMZ VCN or a hub VCN in what we call a hub-spoke model, right? When we deploy the hub VCN, we have the chance to deploy a firewall appliance with it, right? And currently, we support Palo Alto next generation firewall and Fortinet's FortiGate firewall. And the deployment topology is the same for both. We deploy a pair of appliances in an active mode in between 2 network load balancers that essentially load balances traffic, to those 2 backend servers. And with this kind of approach here, we support east-west traffic and north-south traffic through different endpoints. So the one in the indoor subnet will handle east-west traffic, while the one in the web subnet handles north-south traffic. Besides the third-party appliances, the landing zone also supports the inline deployment of the OCI firewall native service. And it is already a high available service. So deploy a single instance, but behind the scenes here, you have more than 1 instance. And without the necessary network security groups to secure the OCI firewall interfaces and the load balancer, right? That essentially load balances to your backend applications, right? So in this kind of mode here, the user access happens through the hub, so they flow through the firewall before hitting the application endpoints. So this is true for the previous scenario as well. So the OCI core landing zone, as I said before, it follows what we call a programmatic style paradigm, or a single stack, in the sense that it makes some decisions on your behalf. It exposes some variables. There is a resource manager UI where you provide values to those variables, and the backend Terraform builds the required input to the backend modules. And the interface is something like this. Right? On the other hand, we have a different approach, that we call the declarative style landing zone. Right? A declarative style landing zone fulfills the use case where customers needs more flexibility to create their own landing zone, right? Because they may say, okay, I get the core landing zone, all it provides, all the automation, but I have so much different compartment and network topology, right, that I really need to provide my own landing zone. So then, of course, there are ways to do that. One, of course, if you know Terraform, you can create your own landing zone using Terraform from scratch, right? You can customize the core landing zone Terraform code, or you can simply declare your landing zone in JSON or YAML using the backend modules, the same backend modules that are used by the core landing zone, right? And you don't need to write a single line of Terraform. As long as you understand and you have plenty of examples, right, that illustrate how to declare many different types of compartment topologies, network topologies, right? You can just declare them in JSON or YAML. And so the core landing zone is compliant with the CIS Benchmark 200, and we are working right now to certify it. The CIS landing zone is certified, but as we understand now, it's being updated, right, by the core landing zone, and we need to submit the core landing zone to CIS certification again to get their seal. And the important URLs are here. But this is not all, right? Together with the Terraform automation in this framework, we have what we call a CIS compliance checker, which is a script, a Python script, that checks if your tenancy is compliant with the CIS benchmark. And you can pretty much use this to validate a core landing zone deployment or your own deployment that you built using the declarative style landing zone, right? Or it might be just the case that, let's say you don't have a landing zone, right? You don't call what you have a landing zone, but you have a set of resources deployed. And you want to know how compliant you are with the CIS benchmark. You can just run this script. So this script will check back against the document, the benchmark, but it also has options to check for OCI best practices that are not in the benchmark. Like if you have redundant connections for Fast Connect, site-to-site VPN, if you have a budget, right? If you use custom recipes for CloudGuard targets, right? If you're using a service connector hub to collect your logs across the tenancy, these are all best practices that the script will tell you about. And the script, the reference is also here, and the script is certified by CIS itself. So it's a certified assessor for OCI. Now I just have two quick demonstrations here. I'd like to tell you guys about how to deploy the core landing zone using the resource manager interface, and then how to execute the script and what it provides us. So from the public GitHub repo of the core landing zone, we have this deploy to Oracle Cloud button that you can just click and start the deployment process. You click that button, you'll be required by OCI to log into your tenancy. So you provide your tenancy name here, username, password, MFA. So you go through that login dance, and you land into OCI Resource Manager page, right, where we essentially create a stack for the landing zone. So you accept the terms of use, you give it a name. So this is the name of your stack. You put the stack in some compartment, and then you click, you see the Terraform version is 1.5, you click the next button, and now you start providing the values to deploy your core landing zone instance, right? So here we're giving it a core LZ service label. That label name is used to prepend, it's prepended to all resource names, so you don't get into name clashing. Here I'm deploying one 3-tier VCN. You could see the CIDR range. The benchmark requires us to provide events and notifications to network and security events. So we have to provide an address here. So these addresses will be sent emails about changes in infrastructure. I'm deploying CloudGuard, you can see. I'm deploying security zones and other security service. I'm enabling the service connector. Remember the logging consolidation. I'm going to use a stream as the target for all logs that I collect. I enable the vulnerability scanning service. I create a default budget, and I put an email here to be alerted by important events regarding the budget service. So very quickly, I provide all this, and then I unselect the run apply here because I want to run a Terraform plan before. So I hit the create button. I land into resource manager stack screen. I run a plan. This is pretty much like running Terraform plan, right? But we're running through the service. So the plan goes, it takes a little bit, but you see it succeeds at some point, and it says that it's going to add 101 resources in a single shot, if you will. Then you click the apply button, and you pick the plan that you just created. You hit apply. And when you hit apply, that's when rubber meets the road, and at some point this apply succeeds, and you have your apply completed, and 101 resources were created. So this is how easy it is to deploy the core landing zone. Of course, if you get into more of the networking weeds, you have to know a little bit of what you're doing, but fortunately we have a deployment guide that can guide you, right, to the required steps that you need to deploy the architecture that you need. And now I'm going to show you how to run the compliance checker, not the recording. And in this checker, we use the Cloud Shell. Cloud Shell is an OCI service that provides you a little, Linux machine in the cloud. You can execute some basic, very interesting stuff like OCI CLI, Terraform, Python, for instance. And here we are creating a folder where we're going to have the CIS checker executed for us. We download the file directly from the public GitHub repo. We got it here, right? And now we are going to execute it. It's a Python script. So we execute as the credentials that are logged in, that we are logged in the console. And the script goes through all the subscribed regions. It does a full search across all your tenancy, all regions, and it reports a summary with some detailed actionable items you see. So here I'm zipping whatever it gave to me. I'm going to download it back to my machine. Right? So provide here where I want it to be, or the file, sorry, the file. And it got downloaded, and then I'll open it up. There is a nice HTML report that says where you are compliant. And you see a bunch of yeses here, good signs. But there are not so good signs. Down here, we see areas where we're not compliant. Then you click a CSV file there at the right-hand side. When you click that, you open up the Excel spreadsheet. And this Excel spreadsheet, you have a dip link there, right? You see this dip link. By the way, the two entries here are of course, the findings. And in that dip link, if you click, it takes you to the OCI console exactly in that resource page that you can pretty much remediate. So it's the full cycle, right? We identify, we provide you a summary report, and then a detailed report with a dip link that puts you right in front of the finding in OCI that you can fix. So Josh, I think with that, I turn it back to you.
Thanks so much. I really appreciate everyone joining today. I want to remind everyone about what you guys got to see, about how we're doing our best to make it as simple and prescriptive as possible. We're doing our best to deeply integrate our services, not only through across the board of our IaaS services, but as well as for PaaS and SaaS, and how we're giving you the control to define your environment. And as Andre pointed out, we have a variety of guidances to deliver this, whether you be it a centrally managed one or more of a distributed infrastructure.
All right. Thank you, Josh and Andre, for an awesome session. We really appreciate your time and help. I hope this was a good learning experience for everyone.
There is a question from Vishalaksha. Essentially, it is advisable to implement the CIS landing zone in an existing brownfield tenancy that was configured a few years back and running the production load. So the answer is yes, you can implement a CIS landing zone in a brownfield tenancy because you can always move resources right into a new set of compartments, right? But you can also run the compliance checker, right? The compliance because maybe it might be the case that your current topologies might be very different from the CIS landing zone. So one recommendation here is to run the compliance checker against your tenancy, see how compliant you are, right? And it might be the case that you just need a few adjustments, right, to be compliant with the benchmark. You don't need to deploy the core landing zone as is, right? You can make what you have, a CIS compliant landing zone too, right? Remember, the CIS, the core landing zone is a specific network compartment and network topology that implements the benchmark, but that's not the only CIS compliant landing zone that you can have.
If you enjoyed this session and would like us to conduct personalized training sessions for your organization, do email us at our personal training email and we'll reach out to you. If you want us to conduct just a hands-on lab, we have our duly designed Quick Shot Live Lab program for a more expedited hands-on learning experience for specific cloud topics. Under the Code Innovate program, we co-develop a solution based on your own use case. Please remember that personal training is an investment we make in our customers to help them grow and develop their OCI skills at no extra cost to them. Our next session will cover identity and access management on February 10th. In this session, you will be introduced to fundamentals of identity and access management on Oracle Cloud Infrastructure and how to start your account off correctly with best practices. With that, thanks for joining today's session and have a wonderful day.
Thank you all. Appreciate it.